Good day, everyone. I'm Arvin Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the topic Future and Present Values of Simple and General Annuities under your General Mathematics from Quarter 2, Module 5. Our lesson objectives. At the end of this video lesson, you are expected to identify the given facts and choose the proper formula to be used in computing for the future and present value of simple and general annuities, and compute the future value and present value of the simple and general annuities. Let's now deal with the future and present values of simple annuity. Have you ever tried getting an appliance by applying in a home credit, FlexiFinance, or through credit cards? If yes, you will realize that this lesson is the direct application of this. With this, you can also see or compute how these lending institutions really work. You will also realize if they are worth it. Most of us had the experience of making a series of fixed payments over a period, such as rent or car payments, or receiving a series of payments for a period of time, such as interest from a bond or CD. These recurring or ongoing payments are technically referred to as annuities, not to be confused with the financial product called an annuity, though the two are related. There are several ways to measure the cost of making such payments or what they are ultimately worth. Here's what you need to know about calculating the present value or future value of an annuity. So for our first part of this video lesson, we're going to compute for the future and present value of a simple annuity. Let us now deal with the definition of a simple annuity. So when we say simple annuity, is a type of annuity in which the payment period is the same as the interval period or conversion period. So what are those conversion period? So it can be by month, semi-annually, by quarter, or per annum. So those are conversions period. When the length of payment period is the same with the length of the interval period, then we can say that this annuity represent a simple annuity. So here are some of the more good example of this simple annuity. First is the monthly payment where interest is compounded monthly. Yes, it is, no? First good example is the monthly payment where interest is compounded monthly, where the payment period is per month and the compounding period is also per month. So the application of the interest is per month or it is compounded monthly. Next example, payment period refers to the time between successive period of annuity. So here is the good definition of a payment period. So it refers to the time between successive period of annuity. Next, term. So it can be time or term. So it refers to time from the start of the first payment up to the last payment. So it will start from the first payment up to the last payment. So that will be your term. From your first term up to the last term. So here, Your periodic payment R, so we simply use your big letter R to represent your periodic payment. If we are trying to or if we're asked to draw a time diagram where we can represent this periodic payment by simply using your R if there's the given values on it, is the size of each annuity payment. So your periodic payment, it should be fixed, It should be fixed with a fixed uh, interval period. So for us to visualize more what is a simple annuity and how we compute uh, the present and future value of a simple annuity, let's deal with these concepts or situations being given to us with the title, How Much Will I Earn? You decided to join a Kabataan Savers Club which aims for financial growth of the youth nowadays. If you pay 1,000 at the end of each month for 5 months on account that pays interest at 5% compounded monthly, how much money will you have after 5 months? So here is the guide questions. First, what type of annuity is present in the problem? So you're asked to describe what type of annuity is present in the problem. Second, what were the given presented? And third, what formula should you use to solve the problem? And for the fourth question, what would be the answer in the problem? So those are guide questions that we can use for us to visualize more what this problem is representing. So for us to visualize that, let's answer the following questions. So the future value of an annuity is the total accumulation of the payments and interest earned. Meaning to say, when we say a future value of an annuity, it's the combination of payments and the interest earned of the principal on each of the periodic payment. Now, for the present and future value, we have here your formula designed for us to compute for your present value and for your future value, which is under to your simple annuity. So under your present value, so there's a formula here that your P is equal to R multiplied by 1 minus 1 plus I raised to negative n all over your I. So where P is the present value, your R is the periodic payment, so that will be your big letter R here. That will be your periodic payment. Your K is the interest rate per period. So that will be your K there, or simply we compute this, So it is always given to a problem the interest rate per period. So that will be the value of K. Now, in this case, for us to solve the value of I or the annual rate, that will be your I, we just simply divide, your periodic payment to your interest rate per period. So that will be the value of your I now, or is simply equal to your R over your K here. So that will be the value of your I or annual rate. Now, your M is the number of conversion period in a year. N is the total number of conversions. So for example, if, how many quarters are there if the given T or time or term is 5 years? So we just simply multiply 4 since there are 4 quarters in a year. by 5 for us to compute how many quarters are there, no, in 5 years, within 5 years. So that will be 4 multiplied by 5, it's 20. Meaning to say the number of conversion period is 20 for that particular scenario. Now, here your n is equal to t multiplied by m. So we just simply multiply your m if that is compounded uh, quarterly. So there are 4 in a year. No, your m is 4. If that is compounded semi-annually, your m is 2. So we just simply multiply it by t, and t is the number of years for us to get the value of your n. So it's the same scenario with your future value of your simple annuity here. It's the same process on how we compute your I, your N. It's the same process on how we multiply your T and M. No? The only difference in between your present value and the future value is the representation of the variables involved and the formula, no? In the formula being designed, no, for your present and future value. So for the future value, that will be equal to R multiplied by 1 plus I raised to n minus 1 all over your I. So here, your F is your future value. Your big letter R in your formula is your periodic payment. So it's a typographical error here. So it's a big letter R. So your K is the interest rate per period. It is always being given on the problem for us to compute for the value of the annual rate, which is your I. So in this case, with the example presented a while ago, we can answer the following questions. Since the interest conversion is equal or the same as the payment interval, so we will use simple annuity. For number 2, identifying the given facts. We have for your P, which is your 1,000 pesos, and your I raised to 12 minus 0.05, that will be 5%, and your N minus 5. So we're going to use these facts from the given values on the example presented a while ago. For number 3, since we will find the amount of money after 40 years, we will use the formula F is equal to R multiplied by 1 plus I raised to n minus 1 all over your I. So this will be a formula for your future value now. And for number 4, then substituting all the given facts, we will obtain, so we just simply substitute all the given values from the given example or the presented on the example presented a while ago, no, that your F now is equal to 1,000 multiplied by 1 plus 0.05 raised to 5 minus 1 all over your 0.05. Now, your future value is 5,525.63 pesos. So this will be your future value for this given example. So for example 1.b, contrast in calculating the future value. A present value Phoebe tells you how much money would be required now to produce a series of payment in the future. Again, assuming a set interest rate. Using the same example a while ago, the given is as follows. Your P minus 50 pesos, your I raised to 12 minus 0.5, N minus 5, As you can see, since we are looking for the present value, we use the formula. So here is the formula designed for us to compute for the value of your present value, wherein your P or PB is equal to R multiplied by 1 minus 1 plus I raised to negative n all over your I. So by substituting it in the formula, we will obtain, as you can see, we just simply substitute the given facts here to your given formula for your present value. And after substituting the given value, we can now arrive to the resulting value for your present value, which is 4,329.48 pesos. As you can notice, the future value is higher than the present value. Why is that? Because your future value is equal to your present value plus the interest being applied to your present value. That's the only reason why your future value is higher than the present value. There is no such thing as, or there is no such thing that your present value is greater than your future value. Because your future value, by simply applying the definition, your future value is equal to your present value or your principal plus the interest applied to it. So in a short word, or in a short or in a, if we summarize, no, the concept of your future value, it is always higher than the present value. So this is because of the time value of money, the concept that any given sum is worth more now than it will be in the future because it can be invested in the present. Yes, it is, no? That's the only reason why your future value is higher than the present value all the time. Let's go now with the definition of a cash value or cash price. Your cash price or cash value is equal to the down payment, if there is any, plus the present value of the installment payments. We can visualize more this concept of cash value or cash price when we decided to apply for a loan with home credit or flexi finance, wherein we're asked to pay a 30% of a total cost of the things that we need to purchase. For example, gadget. If the gadget cost is equal to 12,000, so whatever the 30% of 12,000, that will serve as our down payment. And the remaining uh, to the cost, no, the total cost of that particular gadget, for example, will be converted to an installment payment. So this concept of cash value or cash price are visible now in different malls because of home credit and flexi finance. So they are private institutions or private lending company wherein they they make funds available for customers, no? For example, if we decided to buy a gadget but our money are not enough, no, to for us to buy that particular gadget, then we decided to apply for a loan with home credit or flexi finance. So the concept of this cash value or cash price, no, and that will be equal to a down payment if there is any. It's automatic that there is a down payment when you decided to apply for a home credit. That is 25% or 30% of the total cost of that particular thing that you decided to purchase, no? So, meaning to say, your cash value or cash price are more visible now than before. For example, 1 point C, Mr. Angeles paid 200,000 pesos as the down payment for a car. The remaining amount is to be settled by paying 6,200 pesos by the end of each month. If the interest is 10.5% compounded monthly, what is the cash price of his car? To solve this, let us identify the given. So if you identify the given values, your the down payment is now equal to 200,000 pesos. So the interest being applied on it is 0.105, or if we convert this 10.5% to decimal, that will be equal to 0.105 divided by 12 because it is compounded monthly. That's why we divide this 0.105 by 12 for us to get the value of your I, which is now 0.0875. Then your N is 60. Yes, it is 60, no? And your P is 16,200 pesos. So that's how we see it. So for us to obtain the present value of the car by plugging the given in our formula or by simply substituting the given values to the design formula for your present value, so we substitute 16,200 multiplied by 1 minus 1 plus 0.00875 raised to negative 60. So that will be the number of months within 5 years. That is 5 multiplied by 12, so it becomes 60. So negative 60, raised to negative 60 all over your 0.0875. So upon solving this one by simply using your calculators, the resulting value for the present value of the cars now is 753,702.20 pesos. So to get the cash value, simply add the obtained present value and the down payment made. Yes, it is, no? We just simply add your down payment, which is 200,000 pesos, plus the present value of the car, which is 753,702.20 pesos. So the total cash value of the car is 973,702.20 pesos. So that will be the total cash value of that car. So for example 1.D, Mr. Edgar borrowed from his friends 200,000 pesos and he promised to pay the amount plus its interest by an equal amount of money each year for 5 years. What must his annual payment if they agreed on an interest of 10% compounded annually? So the interest will be applied through a compound interest per year. So this example is different from the examples presented a while ago. This time, you are going to compute the regular periodic payment. We will be manipulating the formula of present value to obtain the formula for the periodic payment. Now, with this one, with the concept or with the formula designed for the present value, we can actually compute for the periodic payment by simply transposing or transferring some variables from one side to another side of the equation, and for us to get the unknown variable, which is your regular periodic payment. And for the given value, your P is equal to 200,000 pesos and your I is equal to 0.10 because it is 10% compounded annually. So we don't need to divide this one by 12 because it's already compounded annually. If that is compounded monthly, we divide it by 12. But since it is compounded annually, you don't need to divide the 0.10 by 12. So we adopt the 0.10 as a value of your I or rate of interest. For the value of n, that will be equal to 3. Now let's try to substitute, no? By simply substituting the values to our formula, we get this one. So your R now is equal to 200,000 all over your 1 minus 1 plus 0.01 raised to negative 3 over 0.1. So upon computing the value of your regular payment, no, here we can actually look for the value of your R. And the resulting value is 80,422.96 pesos every year. So this will be the regular periodic payment wherein your Mr. Edgar must pay, no, every year. He needs to pay 80,422 pesos point 96 centavos every year. So that's how we compute for this given value. So why is that it is 3? So we can, and not 5, because if you use your time diagram we're after, no? We just simply look for the regular payment. So if we put 1, 2, 3, that will be mapped to your R. So we can actually consider, so whatever the time interval here and time interval from 2 to 3, it's the same, no? Regular payment here up to the last to the fifth year. So we can actually compute for the value of your R even if we consider 1, 2, and 3 as a value of your N here. So for the future value and the present values of general annuity, so in this course, you will solve all sorts of general annuity problems. A general annuity is an annuity where the payments do not coincide with the interest period. Yes, it is. They are not the same. You will be able to see that it is very easy to deal with general annuities once an equivalent interest rate is determined, with the equivalent rate being compounded as often as the payments are made. Yes, it is, no? That's the good thing in your general annuity. So what's in? Why do you need to know investments? Bonds, stocks, interest. Why is there a need to invest your hard-earned money? No? It's a total different thing, no? Once you put your hard-earned money on a bottle or a saving bottle, no? It is uh it is better for us to decide that we're going to invest this hard-earned money, no, for us to earn more money because of the interest being applied on it. So having the knowledge in basic concept in business mathematics or the mathematics of investment may help you decide whether to use the credit cards for 5% interest compounded monthly or a simple interest for a period of 6 months. Some topics might shed light on which banks would you give a higher interest rate for your savings. For you to begin, consider the lesson on the previous module, which is essential in obtaining success in this lesson. General annuity is not like a simple annuity. Yes, it is, no? Unlike simple annuity, general annuity deals with different payment period and interval period. Here, you have to convert the rate first before substituting the values to the formula. Yes, it is. That's the only difference no, between your simple and your general annuity. That the payment period is not the same with the interval period. So let's us now deal with the formal definition of your general annuity. Again, your general annuity is a type of annuity in which the payment period is not the same as the interval period or conversion period. You will be able to easily identify this. Yes, it is, no? Again, what's an annuity? That there is a payment period which is not the same with the interval period. That annuity represent a general annuity. So for example, let's deal with this example for us to visualize more what is a general annuity is. So a 4-year lease agreement between Alfred and Tripty Mall Incorporated or TMI indicates that Alfred pays TMI 100,000 pesos at the end of every year. If the agreed interest rate is 5% compounded quarterly, in this example, the payment period is a whole year. However, the interest period is quarterly or every 3 months. Hence, the annuity is general annuity. Why? Because the payment period is every year. But again, the compounding period or the interval period or the conversion period, I mean, is that it is compounded quarterly, meaning to say that the interest period is quarterly or every 3 months. So there are 4 sets of 3 months in every year. There are 4 quarters in every year. No, if for us to look for the value of the conversion period, we just simply multiply the number of quarters in every year to the total number of year, no, being given on this example. So that will be the number or the value for that conversion period. Here, for the future value of an annuity, which is now for your general annuity, is the total accumulation of the payment and interest earned. Yes, it is now. It's the same definition with your simple annuity, but different concept. What you are dealing now, what you are dealing with your general annuity. The present value of an annuity is the principal that must be invested today to provide the regular payment of an annuity. Now, for your general annuity, let's deal with your present value and your future value F here. For your present value, your R will be multiplied by 1 minus 1 plus I raised to negative n all over your 1 plus I raised to b minus p, where your R is your big letter R is your regular payment, your K is the interest rate per period where I is equal to R over your K. I is the annual rate. Yes, it is, no? That's why if that is compounded quarterly, you need to divide it by 4 for us to convert this one to an annual rate because there are 4 quarters in a year. M is the number of conversion period in a year. N is the total number of conversion period. Again, if that is compounded quarterly, we just simply multiply 4 by the total number of years being given in the problem because there are 4 quarters in a year. Then N now is equal to T multiplied by M. Your B in your formula is your P over C, where P is the number of months in a payment interval and C is the number of months in a compounding period. So that's how we compute for the value of B, no, in this formula. So it's the same process on how we compute for I, your N, and your B, no? It's the same process for once we are asked, no, to compute for the value of your future value with this general annuity. The only difference that on how we manipulate your variables in the given or in the design formula for your future value. Now, for your future value, your formulas are multiplied by 1 plus I raised to n minus 1 all over 1 plus I raised to b minus 1. So that's the formula designed for your future value. Again, on how we compute your I, your B, your N, it's the same process on how we compute your I, your B, and N in your present value. So for example 2.A, if you will notice, the interest conversion period is different from the payment interval. So since this is the case, we will refer to general annuity. So consider the following given: your P, or your present value, is 2,000 pesos. Your N is 9 multiplied by 4, that is 36, no? When your I is 5% over 4, because it is compounded quarterly, that's why we need to divide by 4, so that it becomes 0.0125. Your C is 3, that is compounded quarterly. Your P is 12, because the payment period is every year. Your B is equal to P over C, which is now equal to 12 over 3, or simply equal to 4. So with the given values here of your P, your N, your I, your C, your P, and B, we can now substitute these given values to the design formula for your P or PB, or your present value. In this case, your R, this is a typographical error here. This is R, or the a periodic payment, which is 2,000 pesos. So if we convert, if we substitute this one, that will be 2,000 pesos multiplied by 1 minus 1 plus 0.0125 raised to 36, because there are 4 quarters in a year. Multiply by 9, that is 36. So plus all over 1 plus 0.0125 raised to 4 minus 1. So if we try to use your calculator, the resulting value for this formula is 14,155.99 pesos as the present value of this general annuity. So that's how we compute for the present value of the general annuity on this given example problem. So for example 2.2, looking for the future value of the example a while ago, no? Let us use the given, which is your R. This is your R. It's a typographical error. Your R, or your periodic payment, is 2,000 pesos. Your N is still 36. Your I is still 0.0125. Your C and 12 now, plus the value of your B, are still the same with this example 2.B. So using the formula for future value, your future value now is equal to R, or your periodic payment, to be multiplied by 1 plus I raised to n minus 1 all over your 1 plus I raised to b minus 1. So this will be the formula for your future value. Upon substituting all the given values in this formula, your F now is equal to 2,000 multiplied by 1 plus 0.0125 raised to 36 minus 1 all over 1 plus 0.0125 raised to 4 minus 1. So the future value for this one is 22,139.17 pesos. So that will be your future value for this example 2.B using all the given values for example 2.A. So for your activity, solve the following problems. First problem, the buyer of a lot pays 50,000 pesos cash and 10,000 pesos cash every month for 10 years. If money is 8% compounded monthly, how much is the cash price of the lot or the cash value of that particular lot. For number 2, annual payment of 1,000 pesos at the end of each term for 8 years with interest rate of 6% compounded quarterly. So find the present and the future value. So using the concept of your simple and general annuity for present and future value of these two uh, kind of annuity under your annuity certain, no? Then we can solve these two given problems here, and you can put all your answers and solutions using your Katleya. Thanks for watching. So please like, comment, and share, and subscribe.